Hello, this is Divya Patel, and I am doing video project 1, and this is my Bearcat ID card. Alright, so we get data over here, and so first step is you grab your calculator, you go to Stat, Edit, you type in your data. On the X column, you put in 2, 4, 7, 11, 16, and on the Y column, you put in 25, 60, 75, 99, 111. So you're done with that. And you press Stat again, but this time you go over to Calc because you want to calculate linear now. And so you scroll down to line reg, which is number 8. Sorry, my bad. No, not line reg number 4. There's 2 line regs, but the number 4 is the one that I do. And so you get the answer 5.7142, and then you round it to 3 decimal places, so you get 5.714. And so for my calculator, you get like an equation at the top. So it says y equals ax plus b. And then it gives me a and it gives me b. So then I just plug it in to what I see on the calculator and just type it in onto my answer sheet. It's pretty simple. You're just plugging it in. So quadratic, go to calc, go to number 5. It says quadratic. Press OK, calculate. Boom, you get A, B, and C. Formulas on the calculator, you plug in A, B, and C. Pretty simple. Exponential. Calc, you scroll down, you go to number 10. Exponential reg. It says EXP reg. Okay. Calculates. Formula again, plug it in. Pretty simple. Stat calc, you go to logarithmic. This time it's logarithmic, so you go to number 9, which is ln reg. Okay. You see your formula, you find A and B, plug it in. Now we're onto science, my bad. Go to stat, calc, and then go down to sine. And so for my calculator, it's not numbering and it's at letters, so it's at C right now. So you go to sine reg. Okay. And for this one, you want to have, since in the instructions it says 3 iterations, you have to press OK on the iterations and put in 3. And calculate it, and then you get this long function, but it's okay. We have our formula. We're good to go. Logistics, stats, calc. Go down to B, and it just says logistics. Pretty simple. Okay. And then you get your answer, and you plug it in. So now for number 2, for the same data now found. So now I have to find which data doesn't align. So what I did is I went through all of these numbers, went to Desmos, and let's do an example. So this is linear. So I went to A and B and made sure these 2 numbers, these A and B, matched up with this A and B. And so when I went to exponential model, which is this right here, and went to A and B, I got A as 41, and then I checked to my A, and it was 31, which is 10 off. So then I immediately knew that there's a difference between Desmos and my calculator. So, sorry for that. So Desmos is in green, and the calculator is in red. Let me just do the zoom fit. Alright, so I put that Desmos has a slight advantage. And so let me explain why. So when we start off, calculator has an advantage. Calculator is closer to this dot right here, which gives calculator advantage. Like, it's more accurate. But as time goes on, we have these two dots, and Desmos is closer to those 2 dots. And then calculator is closer to this dot, and then it ends with Desmos closer to this dot. And so it's kind of even, 3-to-2 ratio. Desmos is in favor. But the thing for me is, if you have a big number and you want to estimate it, it'll be more accurate if you use Desmos. And the reason why is, as it's ending, this green is very close to this dot right here. And it's closer to this dot right here, which means it'll be more accurate when you're trying to predict larger numbers. So that's why I put Desmos has a slight advantage. And for this next one is sine. So I think this one is kind of weird because, alright, I'll get rid of these two. So this is my sine on Desmos. I mean, pretty easy to read, pretty accurate, nice and simple and clean. But then when I typed this thing out, when I typed my calculator formula out onto this, I got this orange thing, filled it up. And then so that I thought it might have been a mistake or something, but I triple checked and I typed in everything. I typed in this whole equation correctly and how I'm supposed to type it out. And I'm sorry, I typed in this equation and I typed it out accurately and it led me to this. So I thought I made a mistake, but then I did it on my calculator. I tried graphing on my calculator and it's just a blank. It wouldn't work. So then I figured that my TI-84 is not capable of graphing this, and that Desmos is capable. So that's why I say that Desmos is better, is because Desmos is capable of graphing it, and my TI-84 is not capable of graphing it. So what is the R value? So R value is shows like linearity, kind of. So the number will be in between -1, 2, all the way up to 1. The numbers will be in between it. It's like fluidity, kind of. And so I looked through, this is what I did. I looked at the R numbers. This R number is 0.96, 0.97, and then I found my best one closest to the number 1, and which is 0.9908, which is closest to 1. And so that is the best model type with the R value. And so, oops, my bad. But anyways, that is pretty much how I did my work, what I did, and all of these tables right here are Desmos. And yeah, that's how I did my work, and this is Video Project 1. Thank you for listening.